Uh, so welcome back. Sorry for the interruption. And I try to make this videos as short as possible because I know you lose concentration when the video is too long. So let's what were we talking about? So we were talking about mean, median, and mode, and its relation with respect to asymmetric or like positively skewed or negatively skewed distribution. And I also pointed out the value of all these measures. So mean is affected by the extreme outliers. Median is the central value, so it's not sensitive to extreme values as is the median. I'm sorry, the median is not sensitive to extreme values. And mode is the one that happens the most, and mode is the one that's suitable for nominal data. So that might be one important thing. Again, we did look at an example of how to compute mean, median, and mode, so I'll leave this example. So we talk about the benefits of mean, median, mode. Let's talk about what kind of data do this measures apply to. So mean can be used anywhere. So mean can be used on interval data, so that's important. And we also argue that mode should be used in the nominal data. Median is best suited for the ordinal data. So ordinal is nothing but order, right? Remember? So order is 1, 2, 3, 4, 5, and usually it's sorted. So the lowest value is here 50, 75, 82, 99, 100. So if the data is already sorted, you can easily find out the median. So median is best suited for ordinal data. Okay. So sometimes just telling you mean, median, and mode might not be sufficient. You also might want to see what the spread of the data is. So if you're interested in the spread around the mean value, you are usually interested in measures of variability. So one quick measure of variability will be, one naive measure will be the range. So range is nothing but the largest minus the smallest observation. So in these two data sets, the largest observation is 50 minus the smallest, so largest is 50, smallest is 4, largest is 50, smallest is 4. So this range is 46. Okay. So again, this is a very simple measure for variability. It might not be suitable because it doesn't tell you the entire story about this data. So this data more or less looks uniform, so a bunch of 4s and a 50, while this data more or less looks exponentially increasing, some kind of thing. Okay, so just knowing the range might not be sufficient. So we have to develop some kind of measure to find out what the variability is in the data set. And there's this common measure called variance that's used very commonly. So if you talk about variance, this is again, we'll have two classifications. One is associated with the population, one is associated with the sample. So we'll use the one from the sample and try to establish what the population variance can be. So variance is nothing but finding out each observation xi, finding out its deviation from the mean x bar, and then taking the square and then dividing that by n minus 1. Again, remember that this is n minus 1. So always use n minus 1 for, so again, n was the number of observations for the sample. There's this shortcut. I don't believe this is too much of a help, but I will show you how to compute this for this data set, let's say. So again, let me write the formula for reference. So variance s square was the summation I equals 1 to n xi minus x bar the whole square over n minus 1. Okay. So my handwriting is not legible. I'm sorry for that, but this is the best I could do. Okay. So the first step in this is to find out what this x bar is. So we found out that x bar is nothing but x1 plus x2 plus x3 plus x4 plus x5 over 5. Okay, so x bar is summation of that xi over n, remember? So first step is finding out this x bar. So this is 17 plus 15 plus 23 plus 7 plus 9 plus 13 over 5 in these values. So let's find that out. Give me a moment. I'll bring up my calculator. So 17 plus 15 plus 23 plus 9. Okay, let me just erase this measure. Plus 13. So this is 77 divided by 5 is 15.4. So if it's right, then it should be 15.4. So I will suggest that the first step is listing this data like this: 17, 15, 23, 7, 9, and 13. Okay. And then the thing that you want to find out is what is the deviation from the mean. So xi minus x bar. So x bar is 15.4. So this is 17 minus 15.4. 17 minus 15 minus 15.4. 23 minus 15.4. 7 minus 15.4. And 9 minus 15.4. And 13 minus 15.4. Okay. So you found out that. I'll just do few. So 2.4 minus 0.4. What is it? 6, 7. So minus 7.6. Minus 8.4 minus 6.4. So again, I might be wrong. So check me on this. So once you get that, so this is your xi minus x bar. So now you've done this xi minus x bar. You find out xi minus x bar whole square. So you square that thing. So 2.4 square. I will just do few the calculations and then I will go to the results. So 2.4 square is nothing but 5.76. 5.76. This is 0.16 and so on. Okay. And then you sum these values. So this, if you sum these values, you will get this numerator, and then you divide the numerator by number of observations minus 1. So number of observations were 1, 2, 3, 4, 5, 6. So n minus 1 equals 6 minus 1 equals 5. So you divide the whole thing after summing this up by 5. So let's look at the results. I think that will make more sense. Again, I was kind of wrong here, so that's why I told you guys to watch the math. Always be very cautious. So 14 jobs, that's the x bar. You find the deviation. So this is 3. You find this as 1. This is minus 1. Take the square, and you find the variance as 33.2. Okay. So remember that this variance is denoted by s square, and this is the sample variance. So what is this s, you ask me? This s is called the standard deviation, because the units of this variance is in square. So one easy way to correct for that is to just take a square root of that. So if I ask you for the standard deviation, it's nothing but the square root of whatever quantity you got here. So that's 33.2. So it's just the square root of 33.2. Then you can find out something called the standard deviation. Standard deviation is a very important concept, especially for the bell-shaped distribution. So the empirical rule says that 68% of observations fall within one standard deviation of mean. So that means that if this is my mean, let's say 0 is my mean, and this mean again is denoted by x bar here, and this is my one standard deviation. So one standard deviation one standard deviation below the mean, one standard deviation above the mean. This yellow portion comprises of 68% of the observations. So this is 68%. That's the rule. Okay, it's not it is a very nice rule though. Like we use it a lot, and we might use it in the coming chapters. If you move this limit to 2 standard deviation, so somewhere here 2 standard deviation, 2 standard deviation, this area is 95%. So again, this is valid only for the bell-shaped symmetric distribution. When I talk about something like asymmetric distribution like this, it will not be valid. Okay. And then when you go to 3 standard deviation, it is 99.7%. So this is very important to understand, and this is where you can help this empirical rule to find out what the distribution of grades in the classes. So that's all for now. This is the break point, so we will talk about the next things in the next video. I like your opinion on the video. Do you like this video? Do you want to make do you want me to make more of these videos? Let me know. Okay, thanks.